Your heart is going to stop one day. That's not a threat. That's just biology. And in the seconds after it happens, something strange takes place inside your skull. Most people assume the lights just switch off. They don't. For most of medical history, doctors believe the brain dies the instant the heart does. No blood, no oxygen, no you. Simple. It made sense on paper. It matched everything doctors had been taught since medical school. But machines don't lie, and the machines have been showing something else for over a decade now. In 2013, a neurologist named Jima Borjigin at the University of Michigan placed electrodes on the brains of rats and then stopped their hearts. She expected to see a flat line, a slow fade. What she saw instead was a surge. A massive spike of organized electrical activity, more intense than anything recorded while the animals were fully awake and alert. It happened in the first 30 seconds after the heart stopped. The brain, starved of blood, didn't shut down quietly. It lit up like every neuron had been waiting for permission to fire at once. Why would a dying brain work harder than a living one? Borjigin's theory is unsettling in its simplicity. As oxygen disappears, the brain's usual inhibitory systems collapse first. Inhibition is what keeps your thoughts in order. It's the filter that turns raw electrical noise into a coherent stream of consciousness, the same way a dam keeps a river from flooding every field around it. Remove the dam and the water doesn't disappear. It goes everywhere at once. Remove inhibition, and every remaining neuron fires in an uncontrolled, unfiltered flood, with nowhere left to go and nothing left to organize it. This is where the 7-minute theory comes from. Not 7 minutes of life in any normal sense. 7 minutes of something else entirely. A window after clinical death where the brain, drawing on its last stored reserves of glucose and oxygen, runs one final, chaotic process before the cells themselves begin to break down beyond recovery. Some researchers compare it to a power surge right before a building loses electricity for good, disproportionate to everything that came before it. Then gone. Human cases echo this pattern almost exactly. In 2009, an intensive care physician named Lakhmar Chawla studied dying patients across several hospital wards and noticed the same signature Borjigin would later find in laboratory rats. A short, sharp burst of brain activity, sometimes occurring minutes after the heart had already stopped beating entirely. He called it a terminal surge. Families sitting in the room during these final moments often described their loved one's face changing in that instant, as if something had briefly returned before leaving for good. Chawla was careful with his conclusions. He never claimed to know what the surge meant on a deeper level. Only that it happened, and that it happened far more often than the medical establishment had assumed. So what does a brain do with one last spike of energy and nothing left to lose? This is the question that pulled Sam Parnia, a critical care physician at NYU Langone, into one of the strangest research projects in modern medicine. His AWARE study placed hidden images near the ceilings of hospital rooms where cardiac arrest was statistically likely to occur. The logic was simple, almost elegant. If a person's awareness somehow persisted after their heart stopped, and if that awareness really did float above the body the way so many survivors describe in vivid detail, they should be able to recall an image that no one lying flat on a hospital bed could possibly see. Most patients recalled nothing at all. That's worth saying clearly because it matters. But a small number described experiences with strikingly consistent detail across completely unrelated cases. A sensation of moving through a tunnel. A feeling of overwhelming calm that replaced the panic of dying. A presence of light at the far end of that tunnel, pulling attention toward it. Parnia doesn't claim these patients literally left their bodies and observed the room from above. He claims something more careful, and in some ways far more interesting for what it reveals about the brain itself. The brain, even in its final minutes of measurable activity, may be capable of constructing a complete, immersive, multisensory experience using nothing but the last available chemical and electrical resources it has on hand. Picture it like a phone sitting at 1% battery. Most apps shut down immediately to conserve power. The screen dims. Background processes stop running. But sometimes, right before the screen finally goes black for good, one last burst of stored power runs through the entire system, and for a few brief seconds, everything flickers back to full brightness before the device dies completely. That flicker might be what near-death experiences actually are. Not a glimpse of another world waiting on the other side, but a final, electrically chaotic performance staged by a brain attempting to make sense of its own shutdown in real time. The tunnel of light could be explained by the visual cortex losing peripheral input first, narrowing the entire field of vision down into a single bright tunnel, the same physiological process that causes fighter pilots to experience tunnel vision when blood drains rapidly from their eyes under extreme gravitational force. The feeling of calm replacing panic could be a flood of endogenous chemicals, the same broad families of molecules involved in deep meditation, certain anesthetics, and naturally occurring psychedelics, released in one final, unregulated wave as the brain's normal chemical balance collapses. None of this makes the experience less real to the person having it in the moment. If anything, it makes the whole phenomenon more remarkable rather than less. A brain with mere seconds of fuel remaining, somehow assembling something that feels, to the person inside it, completely eternal. Here's a detail almost nobody mentions when this topic goes viral online. The 7-minute window isn't a fixed, universal countdown printed somewhere in human DNA. The actual duration depends heavily on how much oxygen your specific brain was consuming right before your heart stopped, how cold or warm your body temperature happens to be, and how much glucose is still circulating through your bloodstream at the moment of arrest. Cold dramatically slows the biological clock down, which is part of why cardiac arrest victims pulled from icy water sometimes survive with no brain damage despite being clinically dead for far longer than 7 minutes. Heat speeds the same clock up considerably. Some recorded cases of measurable brain activity after cardiac arrest lasted under a single minute. Bourgeois rats showed their entire surge fading within roughly 30 seconds of the heart stopping. The 7-minute figure became popular culture shorthand because it's memorable and round, not because it reflects any precise biological constant. The real range across documented cases is wider, blurrier, and considerably stranger than a single clean number suggests. So why should any of this matter to you, sitting here very much alive, with a heart that has no plans of stopping anytime soon? Because it quietly reframes something you've probably never stopped to question. You assume death works like a light switch. One moment you're here, fully present, and the next moment you're simply not, as if someone flipped a switch on the wall. The research increasingly suggests it works closer to a sunset instead. A gradual loss of light, dimming in stages, with one last brilliant flare of color right before the horizon swallows everything completely. There's a deeper unease hiding underneath all of this too if you sit with it long enough. If your brain is capable of generating something this vivid, this emotionally convincing, using only its dying reserves and nothing else, how much of what you experience as solid, dependable reality right now, while fully alive and reading these words, is also just electricity finding patterns in the dark? The tunnel, the light, the wave of calm. Maybe none of it is evidence of an afterlife waiting somewhere beyond the body. Maybe it's evidence of something closer to home. Evidence of exactly how convincing your own mind can be when it has almost nothing material left to work with. Doctors who study this phenomenon still don't agree on what it ultimately means for consciousness, or whether it means anything at all beyond biology defending itself one final time before shutting down for good. But across dozens of independent studies, in rats, in dogs, and in human cardiac arrest patients, they do consistently agree on the raw observation itself. Something happens in there. A final, frantic conversation between neurons that no longer have any future left to plan for, having one last exchange before the lights, this time actually go out for real. You won't remember reading any of this when your own moment eventually comes, decades or hours from now. There's simply no way to know which. But somewhere in your skull right at this very second, your brain is quietly running the exact same circuits that, one day far off in the future or terrifyingly close, will fire their loudest, brightest, most desperate signal. Your heart is going to stop one day. What happens next might not be an ending in the way you've always pictured it. It might be your brain's single most extraordinary performance, written, directed, and played entirely by itself, for an audience of exactly one, an audience that never gets the chance to talk about it afterward.